Proving the convergence of a sequence using the formal definition can be tricky, but with practice, the process can become second nature. Here's the formal definition. For any epsilon greater than 0, there exists some critical natural number such that the index of the terms of the sequence are greater than that critical value, then those terms will be within epsilon of the limit. If that's the case, we say that the sequence converges to the limit. Here's an example. Let S sub n equal 3 plus 1 over 2n. We're going to prove that this sequence converges to 3. For different values of epsilon, we're going to get different values of n. If epsilon is big, then the sequence will get into the blue zone sooner, so n will be smaller. If epsilon is smaller, it takes longer for the terms of the sequence to get into the red zone, and so this n will be bigger. So what if epsilon is 1/5? And we want the terms of the sequence to be less than 3 1/5. First term is 3 1/2, we're not there. Second term is 3 1/4, still not there. But the third term is 3 1/8, which is less than 3 1/5. So that's the critical value. For every term of the sequence, 3 and on, those terms will be within 1/5 of 3. So we've seen that n is a function of epsilon. And in every problem we have to do some scratch work to figure out the relationship between n and epsilon. So we'll start with the difference between the term of the sequence and the limit has to be less than epsilon. Do some simplifications and some transformations so that we can see how big n really needs to be. N needs to be bigger than 1 over 2 epsilon. To set this up as a formal proof, we'll start by declaring epsilon to be some arbitrary positive number. Then we use the Archimedean property, which states that the natural numbers are unbounded. So for any real number, we can pick a natural number bigger than it. So we know there exists some natural number such that n is greater than 1 over 2 epsilon. Now we need to transform this into something that's going to be useful in the algebra of the proof. So we use some of the same steps here, transform it back into 1 over 2 capital N is less than epsilon. Now we need to show this. So for any n greater than that critical value, starting here, substitute the sequence in the limit, cancel the 3's. At this point we know n is positive, so this is going to be positive, so it equals the absolute value. Now here we've already said that n is going to be greater than capital N. So when we flip it into the denominator, that makes this fraction smaller than this fraction. We've already shown here that 1 over 2n is less than epsilon. And so we see now that the difference between the terms of the sequence and the limit, if n is greater than this critical value, is going to be less than epsilon. And thus we have proven that the sequence converges to 3.